Just 20 kilometers north of Manila, a $15 billion mega airport is rising directly out of the sea. But there's just one problem. The entire thing is sinking, and rapidly. This is New Manila International Airport, and despite predictions that the site could be completely underwater by 2050, developers are racing to complete its 4 parallel runways and 100 million passenger terminal. But the entity gambling money to build this isn't a national government like usual. Instead, it's being entirely bankrolled by a private conglomerate historically famous for brewing beer. Which begs a massive $15 billion question. Why build an airport on sinking land? And more importantly, can infinite corporate capital actually out-engineer the ocean? Or is this destined to be the most expensive infrastructure failure in modern history? Well, the answer to that massive geographic gamble is pure infrastructure desperation. The Philippine economy is currently experiencing explosive multi-billion-dollar growth, but its primary artery to the global supply chain is in a state of near collapse. This is Ninoy Aquino International Airport, Manila's primary gateway. Opened in 1948, it was structurally engineered to handle a maximum of 35 million passengers annually. Today, however, it's cramming over 52 million people a year through its aging infrastructure. But the true root of the crisis lies airside. Ninoy Aquino relies on a severely antiquated intersecting runway layout. And while this X configuration provides flexibility in shifting winds, it creates a fatal flaw. Both runways cannot be safely used simultaneously. If an aircraft is taking off or landing on the main runway, the intersecting runway is entirely paralysed, thus capping operations at just 45 movements per hour. And because the perimeter is completely landlocked by dense urban sprawl, expansion of any kind is physically impossible. Yet, as this aviation bottleneck chokes the city's supply chains, state-level infrastructure planning is completely stalled. The government simply wasn't moving fast enough to fix the gridlock, but if someone didn't act soon, the city's economy could come to a screeching halt. Enter the San Miguel Corporation. Founded in 1890 as a single brewery, San Miguel is now a massive food, beverage and infrastructure conglomerate that dominates the Philippine economy. And with Manila's gridlock actively stalling their own supply chains, they decided to bypass the slow state bureaucracy and made the Philippine government a truly unprecedented offer. And 8 years later, that project is well underway. Rising out of the water here isn't only an airport, it's also an entirely new corporate territory dubbed the San Miguel Aero City. By sprawling across a 12,000 hectare economic zone, SMC will utilise the airport as a gravity well to build a brand new commercial metropolis, integrating industrial logistics parks and a new specialised seaport to plug directly into global trade routes. And at the absolute centre of this reclaimed land sits the terminal itself. While global megahubs like London Heathrow have expanded over the decades into disjointed mazes, San Miguel is opting for a more unconventional approach. It's building a single mega terminal with 240 gates and 5 radial wings. For airlines, this single roof design is pure optimization, drastically reducing aircraft taxi times and guaranteeing hyper-efficient passenger connections. Flanking this terminal will be the ultimate weapon against Manila's notoriously complicated airspace. 4 completely independent parallel runways spanning a 2,500 hectare footprint. Unlike Ninoy Aquino's fatal intersecting layout, these strips are meticulously engineered for continuous simultaneous operations, and handling 100 million passengers every single year. Managing those passengers across 4 active runways will create some of the most densely packed airspace in Asia. To track that level of live compounding air traffic requires absolute precision, and that's exactly why I used the Flight Wall, an airside partner and the sponsor of today's video. The Flight Wall is an LED matrix display that pulls live ADS-B data straight into your room. Using the area tracking mode on their app, I drew a custom polygon over Ninoy Aquino, and the aircraft metrics popped up almost instantly on the board. It displays everything from altitude and ground speed to aircraft type and track in real time as planes pass through the sector. It requires virtually zero technical setup, connects straight to your Wi-Fi, and best of all, there are absolutely no monthly subscription fees. Whether you're an aviation hobbyist tracking planes over your house, or an analyst monitoring wide-bodies over your local hub, it will completely elevate your space. So click the link at the top of the description or check the pinned comment to get your Flight Wall today. But now, back to the video. While the glossy renders of New Manila present an airport ready to elevate the country's economy forever, the reality on the ground is a political time bomb. To fund the mega project, San Miguel secured a 50-year monopoly over the airport's revenues, assuming 100% of the financial risk. But by bypassing the government and rushing construction, they're colliding with an enemy that even infinite capital would struggle to control: the Pacific Ocean. To physically stabilise the seabed, San Miguel awarded a $1.5 billion contract to the Dutch marine engineering giant Boskalis. By 2024, they'd successfully pumped millions of cubic meters of sand to reclaim the initial 1,700 hectare footprint. But in defending the project's ecological impact against outspoken environmentalist groups, San Miguel pointed to a geological reality that exposed the project's greatest vulnerability. The region's low-lying land has historically sunk below sea level due to decades of aggressive groundwater extraction. In other words, the ground beneath this $15 billion airport is actively collapsing. While global sea levels are rising by roughly 3mm a year, the seas surrounding the Philippines are actually rising 9mm annually due to unequal ocean heating. But climate dynamics are only a fraction of the threat. The Bulacan coastline ground is actively sinking at a staggering rate of up to 109mm every single year. To understand why this is happening, you have to look hundreds of meters underground. The coastal plains surrounding northern Manila Bay are built on massive sediment columns consisting mostly of river delta muds, sand and gravel. Under normal conditions, these sediment naturally compact by just a few millimeters a year. Beneath the surface, groundwater is stored in aquifers, sandy layers sandwiched between thick, highly porous layers of clay. But decades of unregulated industrial groundwater extraction have fundamentally broken this subterranean architecture. When surrounding industries aggressively overpump this water out of the ground, the fluid pressure inside the aquifer plummets. The depressurized aquifer acts like a vacuum, sucking water directly out of the clay, permanently reducing the volume and thickness of the clay layers and causing the land above to physically deflate. Oh, and San Miguel's massive construction effort is about to make that sinking effect significantly worse. Slapping millions of tons of new artificial fill, concrete runways and terminal buildings onto this fragile crust creates immense artificial pressure. This massive new weight is proven to speed up the compression of the substrate below, meaning that the airport will actively accelerate its own sinking. Now, if a runway sinks evenly, it's an expensive maintenance headache, but ultimately not a huge deal. But if different sectors of a 2,500 hectare island set at different rates, the concrete will buckle, crack and snap apart, a fatal scenario for an aircraft landing at 150 knots. And to see exactly how this whole situation plays out, we only have to look about 3,000 kilometers north to Japan. In 1994, Japan opened Kansai International, a $20 billion engineering marvel floating in Osaka Bay. Engineers meticulously calculated that the artificial island would sink exactly 13 feet over 50 years before stabilizing completely. But they were completely wrong. Kansai plummeted 27 feet before the first flight ever took off, and today it's sunk a staggering 38 feet into the ocean. To prevent the terminal building from literally tearing itself apart, the Japanese government carried out a series of emergency measures that included 900 structural columns equipped with manual hydraulic jacks. Every 2 years, engineers have to physically crawl beneath the airport and physically jack the building up to compensate for the uneven sinking. And when the sinking outpaces the seawalls entirely, the results are catastrophic. In 2018, Typhoon Jebi completely overwhelmed Kansai's defences, flooding the runways and trapping 3,000 passengers inside a drowning airport. And while Japan might be well known for typhoons, similar weather events certainly aren't uncommon in the Philippines. San Miguel's executives are acutely aware of the Kansai disaster. They understand that pouring $15 billion of concrete directly over a rapidly deflating aquifer is equivalent to financial suicide. To protect their investment, therefore, they cannot simply build on top of the mud. Instead, they're being forced to artificially age the ocean floor by decades before the first terminal pillar is ever driven into the ground. That's where the $1.5 billion contract with Boskalis transforms from simple land reclamation into an all-out geotechnical warfare. To prevent the catastrophic, uneven settling that nearly tore Japan's airport apart, the Dutch engineering giant is executing one of the largest ground improvement campaigns on the planet. Here's how it works. First, massive crawler cranes drive tens of thousands of wick drains into the ground, plunging them up to 40 meters deep into the saturated Bulacan mudflats. But the drains are useless without immense pressure. To generate it, Boskalis deploys a brute force technique known as surcharge loading. They pile millions of tons of excess sand directly on top of the future runway footprints, creating temporary crushing mountains over the site. The sheer gravitational weight of this artificial load physically squeezes the trapped groundwater out of the subterranean clay. That water travels up the drains to the surface, where it's aggressively pumped back into the sea. Once the water is expelled, specialized probes deploy vibrocompaction, shaking the remaining sand particles deep underground into a dense, impenetrable lattice. In macroengineering terms, San Miguel is forcing the land to sink now. By intentionally compressing the soil to its absolute physical limit, they're trying to lock the foundation in place so it won't buckle later when 300-ton wide bodies are slamming onto the tarmac at 150 knots. But this level of brute forcing shows exactly why the project has hit so many bumps. This process burns through capital and it destroys schedules. The reclaimed land must sit under this crushing weight for years to properly stabilise. It's a slow, agonising wait that explains exactly why the project opening of the first runways has already been pushed deep into 2028. The economic stakes of this delay are astronomical. If San Miguel Corporation manages to pull this off, they'll solve Manila's aviation bottleneck and shift the economic centre of gravity of the entire Philippines, cementing a corporate transit monopoly that could legitimately rival global mega-hubs like Dubai or Singapore in the coming decades. They're ultimately attempting to outspend and out-engineer the ocean itself. But if the climate models are correct and the regional subsidence outpaces their billion-dollar countermeasures, this empire will physically sink into the sea. It's a $15 billion gamble that could either become the greatest aviation triumph of the century or the most expensive infrastructure failure in modern history. If you want to track the exact airspace congestion over Manila right now, or see all the traffic flying right over your head, click the link in the description to get your flight wall now. It would really support the channel. And if you want to dive deeper into the science and economics behind the sinking airports, you can find all my research materials in the companion article linked in the description.